Yeah, you are live now. Please proceed.
A very warm good evening, everyone. I, Bhumika Chaudhary, on behalf of UPS CSA, welcomes you all in the session 2 of AWS Bootcamp. Today, we are going to cover about AWS VPC networking. But before that, I would like to shed some light upon the plethora of opportunities that await students at UPS CSA. We are ecstatic to present before you all the opportunity to be the part of UPS Cloud Security Alliance, the first student chapter of International Research Organization Cloud Security Alliance in Uttarakhand. We provide you with a variety of committees to choose from, an abundance of opportunities to avail that is directly provisioned by our collaborators like AWS Educate Student Community India, NVIDIA, Code Warriors, AWS User Groups Dehradun, and Give My Certificates, to name a few. Now it is a moment of sheer delight that we have Mr. Saurabh Bhattacharya, Senior Technical Trainer and Evangelist at Amazon Internet Services Private Limited. Overall, he has an 18 plus years of industry experience in both India and abroad, worked as hardware support, network administrator, team lead technical advisor, technology evangelist, technical manager, and senior technical instructor. We are grateful to have you, sir. Over to you now.
Hey, thank you, Bhumika. Really appreciate it, and really warm welcome to everyone who has joined this particular session. Just a quick check, folks. If you are able to hear me properly, may I have a yes somewhere on the chat or comment somewhere, just to ensure that you are all able to hear me properly. So there might be a comment section somewhere where you probably might be able to type. Okay. Thank you. Great, I'm able to see it now. Excellent. All right, folks. So, what we are going to do today is see when we talk about AWS, right? And then some of you might be from developer background, some of you might have some hands-on experience on AWS, and some of you might be using some of the serverless services which we have. For example, Lambda and API gateways and databases which we have, right? uh, what I thought for today's session was to start off from the basics, okay, from the networking perspective. Because when you go and log into AWS platform, what happens is you get a default, what we call it as a VPC or a virtual private cloud, and then you can launch your EC2 instances inside it, and you can, pretty much do anything which you want. The question is, what if I want to set up my own VPC, like a custom VPC, right? Now there can be multiple reasons. Some people might not create it, and one of the most prominent reason would be that they are not from networking background, right? So probably some of us, we don't understand the networking basics, and some of us depend on other colleagues or friends for the networking part. So I thought today I'll take you up from that basics, from that scratch, so that you all should be able to create your own VPCs. And the good news is, you all can create these VPCs in your free tier accounts, and then there won't be any charges as well if you create a VPC, right? Because VPC is a free service, and it's just a virtual construct. And I'll show you how you can create it, how you can define the routing, and I'll do take up this particular session from the whiteboarding perspective first, so that we will understand it visually and logically, and then I will take you all through the console and I'll show it to you how we can create it. All right, sounds like a plan to all of you? Yeah. So let's get started. Now, before we start off with the VPC or the networking, we need to understand some basics of subnetting. Okay, and I want to keep this session quite engaging. So I might be asking a lot of questions to all of you. It'll be closed-ended question. I mean, I'll be just asking yes, no, true, false, something like that, and may I have the responses? All right. So the first thing, how many of you are from a networking background and you understand subnetting properly? Just type yes or no on the comment section. Okay. So if you are from networking background, you understand subnetting absolutely clearly, then type a yes. If not, just type a no. All right. And even if you are in the middle of it, you can just type a yes or a no. It doesn't matter. But I want all of you to go ahead and type your responses on the comment section. All right, so I can see few of you are saying yes. I'm still waiting for everyone to go ahead and respond, and that's okay. Maybe you might be in the first year, maybe you might have no idea about networking or subnetting. That's absolutely fine. We are here to learn, right? So we will have a look at it, because if you know subnetting properly, then my job becomes really easy, because then I can simply take you to the console and show it to you. But then sometimes we might face certain people who might not be from networking background. So I thought I'll first probably in that case share some of the networking basics first before I get started. So I can see a couple of people who have said they are not really from networking background. Still waiting for everyone to participate. I mean, we are all in this virtual world. Unfortunately, maybe you can see me, I cannot see you as well. So I don't want to feel that I'm speaking to walls. So I would really really appreciate if you could all be very participative and type your responses, and then keep it like really engaging. Okay. And in the middle, if you have any questions, also just ensure that you go ahead and type it on this panel. Great. So let's get started. The very first thing which I want to start off with, and then I'll be using Paint. Okay, this is one of my favorite tools for whiteboarding, and I'll be talking about few things first, just to set up the context. Okay. So what happens is, folks, we talk about IP addresses, right? From the basics of networking, and IP addresses are of basically two types. We call them as public IP or private IPs, right? Now, how do you get this, public or private IP? There is basically a consortium, which we call it as Internet Authority, or you can see here I have written it as INA. So this INA is basically that, a consortium or the authority which manages, your IP addresses. Okay. And when we talk about IPv4 and IPv6, right? IPv4, it's of 32-bit namespace, right? And there are like 4 bits, and each bit can represent 8 bytes, inside it. So how does it go? If you look at anything like, if you can see here 10.x.x.x, right? So basically, if you look at the IP address, it will be something like this: x.x.x.x, right? So you have 4 spaces, 4 namespaces which are there, and each of these namespaces, they can represent 8 bits underneath. So you can see all together it will become like 32 kind of thing, right? Now, so when we talk about this IPv4, as I said, there are public IPs, and public IPs are internet routable IPs, right? So what do you mean by that? If you need to connect to internet, right, you definitely require a public IP. Just with private IP, you cannot connect to internet at all, right? So that's just a basics. Now, from where will I get it? IANA. So this is the consortium which manages this public IP space. And what IANA has done, they have removed these 3 ranges. Okay. And they have said that these 3 ranges in IPv4 scheme will not be public IPs. I mean, they will not be internet routable IPs. So we call them as private IPs. Okay. So you can see the range like 10.x.x.x or 192.168.x.x. X can be anything. Okay. And then you have 172.16.x.x till 172.31.x.x. These 3 ranges, we call them as a private IP ranges. Now, look at the IP address of your laptops, okay, desktops. If you have, your IP addresses will definitely be from one of these ranges. Okay, so even if you go to your colleges and look at the IP addresses of your systems, the IP addresses of the systems will always be from this range. Now, anywhere globally you go, you will see that you will have one of the private IPs, right? Because they are not internet routable, there is no danger of conflict. So I can have my house, let's say a network, and I can say that I will use 192.168 series, right? And the same IP, you could use it in your house or in your college. It doesn't matter, because both of us, we can't communicate to internet using this IP, and there is no danger of IP conflict or something like that. Yeah, we have to ensure that within our house, within that single network, there should not be duplicate IPs, right? So that is one thing. Now, you might be thinking that, hey Saurabh, although I do have this kind of an IP in my laptop, how am I able to connect to internet? The reason is, you are able to connect to internet because of a gateway. So you do have, everyone will have a gateway. Now this gateway could be your Wi-Fi router, it could be internet gateway in your colleges, right? In the office spaces. So you require that gateway, and only via the gateway you can go to internet. If I say that, okay, you just have this private IP and can you connect to internet, the answer is no, you cannot do that. All right, so I'm just talking about the basics as of now. I'll not go pretty much in depth into it, but just wanted to give you folks an idea. Now, coming back to IP address. So you have an IP address, then you have something which we call it as a subnet mask. Okay, so you might have seen 255 dot something, right? And you have this gateway with which you basically connect to internet. Great. Now let's look at this IPv4 IP address, which is x.x.x.x, which can be anything, any value. And if I look at each of the x, as I said, there can be 8 bits, right? And these bits can be 0 or 1, right? And if you look at the permutation combination, what happens is, if you want to calculate the total number of bits or something, so we call it as a 2 raised to power, right? So we start from the rightmost entity, which we call it as least significant bit, or LSB, and we say 2 raised to 0. All right, will be that value. The next value will be 2 raised to 1. The next will be 2 raised to 2, 2 raised to 3. Like that, you will reach 2 raised to 7. All right. And if you look at the values, right? So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4. Like that, you will reach till 128, right? Now, what I want is, I want you all to calculate these numbers. So just go ahead and sum these numbers, okay? So do 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And please type it on the chat. What is the total value you get? I'll give you like, a minute or so. Just do the simple mathematics and type the value on the chat, on the comment section. Let's see who gets it first. $255. Okay, Murli says 255, right? And that is the right answer. If you add these numbers, you will get 255, right? Now, there is one more number which is not, not written here, which is, what if all these 8 bits are zeros, right? So 0, 0, 0, 0, 0, 0, 0, 0, and which is a big 0, right? So that means if we add that value as well, when all the bits are 0, then we get one more number, which we call it as 255 plus 1, which is 256, which means, if you have 8 bits, right, that means you can have total of 256 permutation combinations, right? It starts from 0 and goes till 255, right? That is the value which you all have received. Now, if you have understood that, now let's understand some other things. Now, if I look at any IP, right? Let's take an example of this IP, which is 10.11.12.13, right? And we convert them into binary, right? So how will we write 10? It will be 00001010. Why 1010? Because if you look at the second bit, it will become 2 raised to 1, and the fourth bit, it will become 2 raised to 3, right? So if you add them, 2 raised to 3 is 8, and 2 raised to 1 is 2, 8 plus 2 is 10, right? Similarly, if I have to write 11, then I will write it as 0000 1011. So this is 11, right? And similarly, you can see this is 12, 1100, and 1101 is 13, right? So any IP address, I can put it in a binary notation, right? Now let's look at an IP address, and just let's add a subnet mask to it so that it can become a network. Okay, so I have an IP address which is a.b.c.d. Okay, a, b, c, d can be any numbers. And what I can do is, if you look at any IP address in IPv4, there will be two parts of it. We will call it as a network part, and then we will call it as a IP address part. Okay, now who decides which bits or how many bits will be network part and how many bits will be IP address part? And I'll explain you what do you mean by network part and IP address part. If I want to understand what is the network section, what is the network portion, and what is the IP portion, what do I need to look? I need to look at the subnet mask. Okay, so for example, if you ever see a subnet mask which is, let's say, 255.0.0.0, right? What does it mean? It means that if I want to write it in a binary notation, it will become something like this. So 255 means all the bits are 1, then all the remaining bits are 0, right? So 255, because you calculated, right? If all the bits are 1, so if you add all of them, you will get 255 dot all other bits are 0. So 255.0.0.0. And what does it mean? It means that we can say that first 8 bits are 1, right? So you can see /8. /8 means first 8 bits are 1, right? Exactly. So we call it as not network port, but we call it as a network section or the network portion of the IP address. Now, whenever you will see a subnet mask as 255 and then 0.0.0, what it means is the first bit of the IP address, which is A in this case, will always remain constant because that is the network part, right? So any IP, if you want to use in this network, then A will always be same. The other bits can change. So you can see A.E.F.G, right? That could be a valid IP. Then A.B.Z.X can be a valid IP. So anything, the second, third, fourth bit, they can change, right? And that means you will get a lot of, options, lot of permutation combinations, lot of IP addresses for your servers, right? Now, let's look at a second example. And in this second example, I'm still taking A.B.C.D, which is the IP address. But this time, I'm taking 255.255.0.0 as the subnet part, right? What do you mean by this? It means that the first 16 bits, so you can see this first 16 bits are 1 and the remaining 16 bits are 0, right? So how do I denote it in a CIDR notation? So we call it as a CIDR notation. I can denote it as /16. /16 means first 16 bits are reserved for network. The remaining bits, you can consume it as an IP address within your network, right? And what does it mean? It means that now the first 2 bits are reserved for network, right? So in the IP address, so if I want to assign an IP address to a server, to a network device, the first 2 bits will not change, which means you can see here A.B will never change. The remaining 2, you can change it to whatever you want, right? Similarly, another IP, you can see A.B.D.S. So A and B are still the same. And the remaining 2, you can choose whatever you want. So we call it as a /16. Okay. Now let's come down and let's look at the last one. Okay, I still have the same IP, which is A.B.C.D. Okay, but this time the subnet mask is this 255.255.255.0, and which means my first 24 bits, you can see here the 24 bits, they are 1. Only the remaining 8 bits are 0. So I can call it as 24 ones or /24 as the CIDR notation. Okay, what do you mean by that? It means that the first 3 bits are reserved for network. Only the last bit I can change. Okay. So for example, instead of A, B, C, D, if I put a number like 10.0.0.0, okay. So which means, and if I say that /24, which means the first 10.0.0, the first 3 bits, they will always remain constant, right? And I can choose the next IP as 10.0.0.1 or 10.0.0.2. or 10.0.0.10, 20, 30, 40, whatever, right? And I can go till 255. Okay. Only the last bit I can toggle, which means if I require, let's say, hardly around 200 IPs or something like that, right? Then slash 24 network is fine with me because I just require around 200, 250 IPs. So slash 24 is more than enough. What if I require, I have more devices, I have more computers, more servers, more, storages, more network devices, routers, switches, all these things. Then maybe I require more than 250 IPs. In that case, I will go with slash 16. Okay. Because with slash 16, I will get around 65,534 IPs. Okay. So that's like a huge number, right? So if I want like thousands of IPs, like up to 65,000 something IPs, then I will go with a slash 16 network, right? And if I want even bigger than that, then I will go ahead with slash 8. All right. So this is all private IPs. This is how everyone is using it. And you might be thinking that, okay, it's only 3 ranges, but how we are able to see like big companies, enterprise companies having like hundreds and thousands of, networks, devices and systems, how they are able to assign IPs because of this subnet mask, right? So this concept, we call it as subnetting. All right. And what we need to understand is this is like just you can say the I'm scratching the surface. All right, because somebody might ask me, you have taken slash 8 and then you have not taken slash 9, you have directly taken slash 16 because I wanted to keep it simple, right? Can I take slash 9 slash 10 slash 11? Absolutely you can, right? And it will become more difficult now for you to do the calculations. All right, now two things. Number one, yes or no, or maybe a thumbs up or whatever you want to put it on the comment section if so far whatever I have explained made sense to you. All of you, come on. I mean, I'll be really happy if I can see everyone who is engaged and participating. All right, so is so far clear to all of you whatever I'm trying to explain? At least the slash 8 slash 16 slash 24, if you will see it anywhere, will you understand what it means? At least, yeah. Okay, I can see a couple of people who are giving me thumbs up and some people are typing yes. Okay, great. Excellent. Now, what is the next step, right? Next step, and this is part of your, probably if you have taken computer science engineering or information technology, then I believe networking comes. All right, it's part of your curriculum. Okay, so I just wanted to give you a glimpse of it. I don't know in which semester it is, whether it is in first year or not, but I remember during my BTech days, I did learn it in, I believe, second year. Okay. But yeah, it has been like 18 years now. Now, another thing which you need to understand is if you want to go and do a dive deep into subnetting concept, let's say whatever I gave you is like a tip of an iceberg, you want to do a dive deep into it, then YouTube, go to YouTube. And this is what I did. I went to YouTube, I typed subnetting, okay, and hit enter. The first 8-10 videos which are coming, okay, whichever those are on the subnetting concept, watch it in one single sitting. And the keyword here is watch those 8-10 videos in a single sitting, because I'll tell you why. Maybe when you look at the first video, all right, you might get confused because it depends on who is explaining it, how they are explaining it, whether their accent is something we are able to catch up or not, right? But if you look at 8-10 videos in the same setting, see, 90% of the things will be repeated for you, right? And this is the best revision which you will have, and you will have a great grasp into that concept. All right, so that's one thing which we need to do. All right, now if you have understood this, what I'm going to do is I'm going to start off with a blank canvas now. Okay, and let's get started with VPC networking. This was the prerequisite, okay, the preamble of the main storm which is coming. Okay, if you have understood this networking, let's give a some thought about what is VPC. Okay, VPC is virtual private cloud. That's the full form which I told you. But what it is, if you want to create your systems, your servers, you want to run your applications on AWS, then the first thing which you need to do is you need to have a VPC. I mean, where would you deploy your EC2 instances? you know and you can only deploy them in VPCs, right? There is a default VPC which Amazon provides you in any region which you go, and the simple reason why they provide you this is because you if you even if you don't know networking, still you should be able to launch your servers, and you should be able to run your applications. But the thing is, if you know okay what it takes, then it's great because you can create your own custom VPCs. Okay, so let's see, and this whole session today, I'll kind of pass you the knowledge how you all can independently, without depending on anyone, will be able to create your own custom VPCs, and you'll be able to launch your own servers, and launch your applications, and you will have complete control over the routing and everything. Okay, so that's the key thing which we are going to do. Okay, so let's get started. The first thing which we need to know is, okay, I'll take some shape. All right, and I will choose a color, and let me create a VPC for all of you. Okay, so let's say this is a VPC. All right, now before I create a VPC, so imagine VPC is your own data center, right? Imagine a company. If you want to open a company tomorrow, right, let's say physical office, so you will have a physical data center as well, in which all your servers and storages and networking, everything will run, right? Imagine this is VPC is your private data center. Okay, we call it as on-prem data center or on-premises data center, right? But VPC is a cloud-based data center. Okay, that's the only difference. So that is the analogy how you can remember it. Now, before we open our data center, what do? We choose a city, right? So will I open it in Uttarakhand, or Dehradun? Will I open it in Missouri? Will I open it in New Delhi, Hyderabad, Bangalore? Where? Similarly, when you create a VPC on AWS, you have to choose a region. Okay, so we have around 26 regions all over the globe, and you can choose any region which you want. So let's say I want to choose Mumbai region. I can choose it Mumbai region, and then I can go ahead and create a VPC. What if I want a North Virginia region, right? US East one. I can choose North Virginia region, and over there also I can create a VPC, right? So this is what a VPC is. I will choose a region, just like I will choose a city. I'll open my data center. Similarly, I'll choose a region. I'll create a VPC. Once we create a VPC, we need to give it some name, right? So let me give it a name. And then, by the way, are you folks able to, see it properly? I mean, the resolution, everything, is it fine for all of you? Simple yes, no on the chat, please. Are you able to see it? What I'm typing, what I'm drawing? Yes. Could anyone quickly? All right. Thank you. Thank you. I was thinking that everyone has gone to sleep because it was, post afternoon session kind of a thing. All right. Thank you. Great. So I have given it a beautiful name as my VPC. So for example, if I'll open a company, I'll name it as my company. Okay. Whatever name you want to give, you can give it here. Okay. I can call it as Saurabh VPC as well. I can call it as whatever VPC which I want. Okay. So I've given it a name. The next thing, so when you open your own company, your own data centers, whatever, all right, you will have an idea how many servers, how many laptops, how many desktops I would require an IP address, because I need to give them all a private IP address, right? So now if you look at it, okay, I might have, let's say, 200 devices only, then it's fine, you can go with a /24 kind of a cider, right? But let's say I don't know, today I'll start small and tomorrow I might grow, right? So to be on a safer side, I will go ahead with a /16 cider. Now I can choose one of those three ranges of private IPs which I've showed you. So I can go ahead with 10 dot series, I can go ahead with 192.168 series, or I can go ahead with 172 series as well. So here for this example, I'm going ahead with a 10 dot series. So I'm going ahead with 10.0.0.0. That's a network which I'm choosing with /16 cider. So /16 cider means I will have around 65,000 possibilities of IP addresses, right? So I can have 65,000 servers if I want. Okay. So what I've done, I've created a VPC in a region. I've given it a name. I've given it a network range. Okay. Now, once I have done that, okay, and somebody is saying increase the font size. So let me see, where is font option? I think it should be in view. No, it's not in view. So maybe I don't know if I can choose it. No, okay, let me try something. Oh yeah, here it is. So I can expand it to 20. Okay. All right, great. So I've increased the font size. All right. So I have my VPC. Now, the next thing is when I talk about AWS, right? So they have regions, and in every region, they have something called as like availability zones. Okay. And availability zones, they are like, isolated data centers, right, which AWS has. So imagine we have a region as Mumbai, and in Mumbai we have three availability zones. Okay, these availability zones, you can imagine them as group of data centers, but they are miles apart, so that no two data centers are on same flood plain or same seismic zones or same tectonic plate zone. Okay, so that if a natural calamity comes, it cannot affect more than one availability zone. Okay, and North Virginia region, for example, it has 6 availability zones. Okay, Tokyo has 4 of them, right? So a lot of these regions, they have 2, 3, 4, 6, like that availability zones. Okay, so maybe I have chosen this as my North Virginia region. It has 6 availability zones. Okay, and what I will do is I will choose 2 of them because I need 2 of them for high availability. That's it. So I will go ahead and create one here, choose one here, and I will choose another one here. Now, out of 6, any 2 is fine. Okay. And I can go ahead and, I will see their names as well. So this is, let's say, AZ 1A. All right. And this one is, let's say, AZ1B. Okay, so our availability zone names are like A, B, C, D, E, F, like that. Okay, so I've chosen 2 of them, A and B. Great. Now, the next thing, which in any company you will find, what the network administrators do, they basically decide, okay, in my data center, okay, I have a data center now, but within my data center there will be some servers which requires internet connectivity, right? But there would be some devices where you don't require internet connectivity. Okay, and what we call them as, we divide them, right? There are multiple ways to segregate within the network. So how do we do the segregation in AWS? We do that with subnets. Okay, so what I will do is I will create public subnet. So let's say this is my public subnet, which I'll create. All right. And when I create my public subnet, it has to be a subset of my main VPC network, right? So my main VPC network is 10.0.0.0/16. So here, the public subnet, I'll name it first as pub sub 1A. Right now I'm calling it as 1A because, or maybe I can say pub sub 1. Okay, A was basically for the availability zone. So I can come to know which subnet is in which availability zone, but that's okay. I mean, you can call it as pub sub 1 because this is my first public subnet. Okay. And then, because my main network is /16, right? And remember, if it is /16, the first 2 bits I cannot change, right? So here also, I will have 10.0. The last 2 bits, I can change it. So I will choose
Hello, guys. Please wait as this is some technical problem we are resolving as soon as possible.
All right, folks, am I visible? All right, folks, just wanted to confirm if you folks are able to hear me properly.
Hello, yes, sir, you're audible now.
All right, great. So I'm really sorry, folks. I think the StreamYard crashed on me on the browser, so I'm back again. All right, not and I've disabled my camera because I was thinking that it is consuming a lot of resources. So hence I've disabled it. And what I'll do is I'll basically start once again. All right, and then we'll take it from there. So just give me a moment. I'll just share my screen and you folks need to tell me whether my screen is visible to you folks. Just give me a moment. Okay, I think it must be visible. All right. And I'll just, type the same name which I had typed earlier. So VPC, and I had taken a cider for 10.0.0.0/16. All right. And then what I had done was out of six availability zones, right? I had chosen two of them. So one was AZ1A and the second one was AZ1B, right? And what I was trying to do was I was trying to create these subnets when my StreamYard crashed. So let me retry it again. And the name which I had given for this subnet was uh, pub sub 1, and I had taken an IP range for 10.0.1.0. Okay. Now I had said that because my main network is /16, the first two bits cannot change, right? And hence I have taken, a bit which is, 10.0, which will remain the same for pub sub 1, and I have changed the other two bits, so it is 1.0. and I need, let's say, 250 IPs in this particular subnet. So I can go ahead with, let's say, /24. Okay, so my pub sub 1 is 10.0.1.0/24. Now the same way how I have created my public subnet, so all my public web servers and all will remain in this subnet, but then I might have some backend things like databases and all. So I will create a private subnet as well, and for private subnet I will name it as pri sub 1. This is also my first private subnet, and I will choose the IP range, which is 10.0, which cannot change. And I can 1.0, I have already taken it for pub sub 1, so I'll take it as 2.0/24 for this particular private subnet, right? Okay, so far is it clear to all of you? Are you able to still see my screen and you are able to look at the things? Yes or no on the chat, please. Just wanted to ensure that I'm still connected. Is it so I'm still connected or not? Hey Bhumika, could you confirm if I'm still audible?
Yes, sir. You
All
are
right,
audible.
thank you. I was not able to see any comments or messages, so I was not sure. Thank you. Now, what I've done is, folks, because this was AZ1A, right? And this is where I had created my public and private subnet. I have a second AZ as well, right? Which is AZ1B. Now imagine that 1A goes down because of some reason. It could be earthquake, it could be flood or something. So I need a high availability kind of an architecture. So hence what I will do is I will choose another AZ as well, and I will name it I will go ahead and create my subnets over there as well. So let me choose my two other subnets, and I will call it as subnet. This is another public subnet, so I will name it as pub sub, but then instead of one I will go with two. Okay, this is pub sub 2, and the range would be 10.0 dot let's say 3.0/24. Okay, and similarly, just like I have created a private subnet as well over there, so I'll create a private subnet here as well, and I will name it as pri sub 2, and the IP will be 10.0.4.0/24. Okay. All right. So far, has everyone able to follow me through properly? Any questions or doubts so far? Is it all good so far? And somehow I'm still not able to see any comments. So I'm assuming that maybe it could be a StreamYard issue. What I'll do is I'll continue. All right. And Bhumika, let me know in case my voice drops or anything where you are not able to hear me. Okay.
Sure,
Now,
sir.
yeah, another thing, what happens is when we create this VPC and we create our own subnets, right? What AWS does behind the scene, AWS puts a router. Okay, and this router you won't be able to see it. This is like a managed device from AWS, so AWS deploys it and AWS takes care of it, but it's a router. And what happens is because okay, so we call it as a main routing table. So maybe I'll try to increase the font, because again otherwise it won't be visible. So let's say I'll call it as rt main. Okay, main means it's a main routing table, right? And in this rt main, by default all the subnets will be associated with this routing table by default, right? And you will also see an entry inside this main routing table again, and this entry would be whatever the VPC network which you have taken, right? So 10.0.0.0/16, you will see that this entry, it will say that it is kind of uh, routed. Okay, I think I have to choose a different option. Hold on. Yeah, and you'll see it is routed locally. So you'll see this entry, whatever your network you have decided for your VPC, you'll see this entry that 10.0.0.0/16 routed to local. You will always see that. You will not be able to see the router, but you will be able to see this main routing table. All right. Now, what do you mean by this local? It means that if there is, let's say if I deploy an EC2 instance, right? So let me choose an EC2 instance and let me deploy it here, right? So let's say this is my server EC2 instance, and I will even name it as EC2 instance number 1. Okay. And let's say it's my web server, and it'll also have an IP address, right, from the same subnet. So subnet is 10.0.1. I cannot change the first 3 bits now because it is /24 cider dot, let's say 5. Okay, so this is a private IP. And similarly, if I create an EC2 which is a database maybe, and I'll create it in this subnet, and I will name it as EC2 number 2, and it'll have an IP which will be 10.0.4 dot, let's say
Hello, sir, you are not audible. Guys, please wait as this is some technical problem from server side. Hello guys, sorry for the inconvenience. As Saurabh sir's StreamYard is crashing again and again, we are having the session on Microsoft. Please join the link as soon as possible. Sorry for that. Thank you.